Hello, today we are going to talk about the properties of triangles. That's basically the rules for all triangles. Before we begin the discussion, it's good to know that triangles are named by two things. It depends on their angles, and there's three types of those, and their sides, and there's three types of those. So first we're going to talk about an angle called the obtuse angle, and obviously this is a type of triangle, and the obtuse triangle gets its name by its obtuse angle. It will have one obtuse angle. If it does have one, then it is already considered to be an obtuse triangle. And if you look at the example provided, clearly the fact that this angle is obtuse or greater than 90 degrees means that the whole triangle is now called an obtuse triangle. Next, we're going to talk about an acute triangle. Now, an acute triangle, all three angles must be acute or less than 90 degrees. So 1, 2, 3, all three are less than 90 degrees. So all three have acute angles. Therefore, this is an acute triangle. Next is a right triangle. In order to be considered a right triangle, the triangle will only have one right angle in it. Sometimes the right angle will be notated with a kind of box notation, or sometimes it will be labeled as 90 degrees. But if it has one right angle, again, this is a right triangle. Now we're going to talk about how triangles get their names by their sides. Now remember, there were three types. First is an equilateral triangle. Sorry about that. In order to be an equilateral triangle, all three sides must be equal to each other. Sometimes it will be notated as the first example, 3 inches, 3 inches, and 3 inches. Sometimes there will be no given measurements, but we have what we have called congruency tick marks. In this example, all three sides have one congruency mark, and since they all have one mark, that means that all three sides, whatever the measurement is, are equivalent to each other. Next is an isosceles triangle. In an isosceles triangle, you will only have two sides that are equal to each other. Again, sometimes the measurements will be written in to make it clear which two sides are equal to each other. Or again, they will have congruency marks to show you that these two sides are equivalent to each other. In this example, they each have two congruency marks, therefore those two sides are congruent. The last example is a scalene triangle. In a scalene triangle, none of the sides are equal to each other. And again, the measurements may be written in, or if there's no congruency marks, that tells you that none of the sides are congruent, which makes this a scalene triangle. Last property of a triangle is that all triangles measure 190 degrees from their interior angles. So all three angles inside of a triangle must have a total of 180 degrees. And we can use this property to find a missing angle. We know that the top angle is 80 degrees and the bottom angle is 50 degrees. What we don't know is what the last angle equals, but we do know that all three of those must equal 180 degrees. So I'm going to think back and combine my like terms, 80 plus 50 to get 130 degrees. Plus x equals 180, and then I can figure out that x must be 50 degrees in order to make this statement true. So by using the property, I have found the measurement of the missing angle.